Hello everyone, today we will start with the second concept, that is increasing and decreasing functions. You can expect either 2 or 3 mark question from this. Depends it is. This year this was asked for 2 marks. Last year it was asked for 3 marks. Depends, it may be 2 or 3 marks. But the concept is simple. Just you have to check whether the function is increasing or decreasing by using the derivatives. Okay, we'll see this one. Let us consider an equation. I'll consider f of x is equal to x plus 2. Now this is a linear equation. I'll consider another equation. F of x is equal to minus x plus 2. Both are the linear equation, right? Here only it differs from here positive sign is there and here negative sign is there. We will draw the graph of this function. Okay. If I substitute x as 0, y will be 2. X is 1, y will be 3. X is 2, y will be 4. Right? The graph of the function will be something like this. Right? So, if I consider the graph of this one, here x is 0, y will be 2. X is 1, minus 1 plus 2 will be 1. Right? X is 0, x is now we have concept 2, right? If you substitute x is 2, this will be 0. So, the graph of the function will be something like this. So here what you have to observe, here the function, the graph of this function is increasing. Here the graph of the function is decreasing. So we can say that this is an increasing function and this is a decreasing function. Is it clear? Only this much. This is an increasing one and this is a decreasing one. For example, if I consider the graph of function like this. Now it is increasing. If I consider the graph of function like this. So now graph of a function is decreasing. We'll consider another one. Now, this is the graph. Now, can you say whether the function is increasing or decreasing? No, because the graph is constant, right? So, here this function is neither decreasing nor increasing. Is it clear? We'll consider one more example. F of x is equal to x square. F of x is equal to x square. It will give you a parabola, right? I'll draw the parabola. Rough diagram I will do it. Okay. So this is the one parabola. Now can you say whether the function is increasing or decreasing? No, right? Because here you can observe this, the function is decreasing. From here to here the function is decreasing. After that from here to next the function is increasing. So this function is neither increasing nor decreasing. Both are there, right? It is increasing as well as it is decreasing. But what we can say, the function, if it is the value of x is less than 0, is it clear? Suppose the value of x is less than 0. If you consider the negative value, the function f of x is decreasing. Okay. Remember one thing, student, you are not supposed to write like this. Okay, you have to write decreasing one. So, if it is x is less than 0, f of x is decreasing. If the value of x is greater than 0, if I consider the positive values, right? It is to the left side of the origin, the function is decreasing. Right side of the origin, the function is increasing. The value of, if it is x is greater than 0, then the function f of x is increasing. Is it clear? For the negative side, the function is decreasing, and for the positive side, the function is increasing. Totally, we can say that the function is neither decreasing nor increasing because both are included here. Is it clear? We will consider another function. F of x is equal to sin x. You know the graph of sin x function. We will draw the graph of this function. So it goes like this, right? So now this will be 0 and this is pi by 2 and this will be pi. Right? So this will be now 3 pi by 2 and this will be 2 pi and so on. Now here also graph is there. We will consider only the positive side. Now can you say the function is increasing or decreasing? Here also both are there. Right? From here to here the function will increase. After that, right, from here to here the function is increasing. From 0 to pi by 2 the cos function is, sin function is increasing. After that, from pi by 2 to 3 pi by 2, the function is decreasing. Again, after that, 3 pi by 2, it will be here 5 pi by 2, right? It is increasing. So if you consider the graph of a sine function, it is neither increasing nor decreasing. But if you consider the interval, then you can say whether the function is increasing or decreasing, right? If I consider the interval from 0 to pi by 2, if I consider the interval from 0 to pi by 2, the sine function is increasing. If I consider the interval pi by 2 to 3 pi by 2, then the function will be decreasing. Next, again if I consider 3 pi by 2, 5 pi by 2, the function is increasing. I mean, for the sine function, if you use the interval, then we can say the function is increasing or decreasing. If you consider whole graph, then it is neither increasing nor decreasing. This is the basic things about the increasing and decreasing functions. Now we will see the actual definition of an increasing and decreasing function. Let us consider, let I be an interval. Okay, to check in the interval, let I be an interval defined in the domain of the I is an interval defined in the domain of the real valued function, domain of the real valued function f. Then to say the function f is increasing, to say the function, the first one is increasing in I for some x1 and x2 belongs to I, and x1 x2 belongs to I, since it is defined in the interval. If I consider the interval, obviously the first value is less than the second value. Can I consider the interval as 2, 2? No, right? I can consider the value as 2, 3. Always the value of first one should be less than the second one. So here, this is, if it is the value of x1 is less than x2, okay, interval, so obviously x1 will be less than x2, so it belongs to the interval, implies f of x1 is less than or equal to f of x2 for all x1 comma x2 belongs to I. Is it clear? If it is a value of x1 is less than x2, equal to is also not possible, right? If it is equal to, then it will be not an interval. So x1 should be less than x2, implies f of x1 is less than or equal to f of x2. For all x1 x2 belongs to I, then the function is increasing. Second one, to say the function is strictly increasing. Is it clear? To say the function is strictly increasing. Now, if it is the value of x1 is less than x2, implies that f of x1 is strictly less than f of x2. Is it clear? If it is f of x1 less than or equal to f of x2, then we can say that it is increasing function. If it is f of x1 is strictly less than f of x2, then it is strictly increasing function. Is it clear? Third one, to say the function is decreasing, directly I write here, to say the function is decreasing, if x1 is less than x2, obviously, right, x1 will be less than x2, implies f of x1, here it is less than or equal for the increasing. For the decreasing, it will be greater than or equal to f of x2 for all x1 and x2 belongs to I. For the decreasing, to the strictly decreasing, obviously it will be strictly greater than f of x2. So fourth one is to say it is strictly decreasing. To say it is strictly decreasing, the x1 is less than x2, implies f of x1 should be strictly greater than f of x2 for all x1 x2 belongs to I. This is for the definition for the increasing, decreasing, strictly increasing and strictly decreasing. Usually we will not use these definitions to find the increasing and decreasing functions. We will use the derivatives. There is a one theorem. By using that theorem we will solve those problems. But remember this one, okay? And there is a one problem based on this one. Let us consider the function f of x is equal to 7x minus 4. Okay, f of x is equal to 7x minus 4. Prove that it is increasing. It is increasing, okay, on R. I mean on set of 4 real numbers the function is increasing. We have to prove this. This one will prove by using this method. Okay, see, we know that if x1 is less than x2, right? Interval if you consider, obviously x1 will be less than x2. So this implies I can write 7x1 is less than 7x2, right? x1 is less than x2. If you multiply by 7, obviously 7x1 will be less than 7x2. This implies if I subtract 4, so 7x2 minus 4 is 7x1, right? 7x1 minus 4 is less than 7x2 minus 4. 7x1 minus 4 will be f of x1. f of x is 7x minus 4. In the place of x, we have considered that as x1. So obviously this will be now f of x1 is less than 7x2 minus 4 will be f of x2. Is it clear? So the function is increasing on R. If it is x1 is less than x2, obviously 7x1 minus 4 is less than 7x2 minus 4. That implies f of x1 is less than f of x2. So the function f of x is increasing on R. Is it clear? So the function f of x is increasing on R. Only one problem is given based on this. Remaining all the problems are based on the derivative. So those are important. Just remember this definition. It's enough. Now we'll see the theorem. This theorem is very important. Okay. We are solving the problems based on this theorem. Okay. Let f be a function. Let f be a function continuous on. Okay. Continuous on, similar to the mean value theorem and the Rolle's theorem. Let f be a function continuous on closed interval a comma b and continuous on closed interval a comma b. So next it should be differentiable on, okay, differentiable on open interval a comma b. Then the function f is increasing. Then the function f is increasing if f dash of x, I mean derivative of that function f dash of x is greater than 0. Is it clear? F dash of x, you have to differentiate that function and you have to check whether it is greater than 0. If it is greater than 0, f dash of x is greater than 0 for each x belongs to open interval a comma b. Is it clear? Then the function we can say that it is increasing function. And to say the function f is decreasing, okay, to say the function f is decreasing if f dash of x, for the increasing it will be greater than 0. So obviously for the decreasing it will be less than 0. F dash of x should be less than 0 for each x belongs to open interval a comma b. Next one more is there. Suppose f is a function is constant. To say the function f is constant. Is it clear? This is increasing one and this is decreasing one. To say the function f is constant, if f dash of x should be equal to 0 or constant. Here the value is c. F dash of c should be equal to 0 for each x belongs to open interval a comma b. Is it clear? What you have to do? Just you have to differentiate the function. Then if it is greater than 0, then it is increasing. If it is less than 0, then it is decreasing. If the derivative of that function is equal to 0, then we can say that the function is a constant. Okay. we'll prove this one. Actually proof is not important, but we'll prove one, okay, by using a mean value theorem. Let us consider that the value of x1 comma x2 belongs to closed interval a comma b, okay, x1 x2 belongs to closed interval a comma b, and the value of x1 is less than x2, okay. We have considered x1 x2 belongs to closed interval a comma b and x1 is less than x2. By using the mean value theorem, we'll use the mean value theorem, okay, because these two conditions are satisfying here. Is it clear? It is continuous on closed interval a comma b and differentiable on open interval a comma b, so that we can use the mean value theorem. By using the mean value theorem, what is the mean value theorem? There exists a, right, there exists a one constant c which belongs to the open interval x1 comma x2. I hope you remember this one. There exists a one constant c which belongs to the open interval a comma, or yeah, c values are x1 and x2, such that we can write f dash of c is equal to f of x2 minus f of x1 divided by x2 minus x1, right? We are using the mean value theorem, not the Rolle's theorem. So f dash of c is equal to this one. By this we can write, see there, f of x2 minus f of x1 is equal to f of c into x2 minus x1, right? Already we have considered that the value of, f dash of c, right? So this is f dash of c. Already we have considered that the value of f dash of x is greater than 0. So we have to prove that it is increasing. So the value of f dash of x is greater than 0. Obviously f dash of c is also greater than 0 because c belongs to the open interval. So by this, what we can write, f of x2 minus f of x1 is greater than 0, right? By this we can write f of x2 is greater than f of x1, or we can write this one by rearranging of same thing. We will take the ulta, f of x1 is less than f of x2. Is it clear? We have considered x1 is less than x2. Here it is. We have considered x1 is less than x2 and we proved f of x1 is less than f of x2, right? Since x1 is less than x2, we proved that it is f of x1 is less than f of x2. So the function is increasing. Is it clear? By using the first definition. If it is this is less than this one, then obviously f of x1 will be less than f of x2. Then we can say that the function is increasing. See this problem. It is given. Show that the function f of x is given and the value of x belongs to r, and you have to prove that it is increasing on r. As I told you, we will use the theorem to prove this one. First we will consider the function f of x is equal to x cube minus 3x square plus 4x, right? To check whether the function is increasing or decreasing, what we have to do? First we have to differentiate this, right? After the differentiation, if it is greater than 0, it will be increasing. If it is less than 0, then it will be decreasing. Anyway, here we have to prove it is increasing. So we have to prove that f dash of x should be greater than 0, right? Remember that. Now we will differentiate this. F dash of x is equal to derivative of x cube. It is 3x square minus derivative of 2x. X square will be 2x multiplied with 3. So this will be minus 6x plus 4. Now can I write this as 3x square minus 6x plus 3 plus 1, right? 4 can be split as 3 plus 1. Now here we will take 3 common. Is it clear? If I take 3 common, what is remaining? X square minus 2x plus 1 plus 1. Now this is equal to, can you say what is this now? Can I write this as x minus 1 whole square plus 1, right? X square minus 2x plus 1. So here you have to observe this one. See, this is x square is there. X square means obviously it will be positive. Positive quantities multiplied with the positive 3 plus 1. Obviously this will be positive. Is it clear? So this value is positive and we can say that it is greater than 0. So by this we can say that f dash of x is greater than 0. This implies the function f is increasing on r. As I told you, don't write like this. You have to write increasing on r. Fine. See this problem. Prove that the function given by f of x is equal to cos x. So trigonometric function is given. You have to prove that it is decreasing in 0, pi. You know that it is decreasing, right? And it is increasing in pi, 2 pi. And you have to prove that it is neither increasing nor decreasing in the open interval 0, 2. First, what you have to do, we'll consider the function f of x is equal to cos x. After that, what we have to do, you have to differentiate this function. So derivative of this f dash of x will be equal to derivative of cos x will be minus sin x. Right? Now we'll check with the first one. A. We'll consider since the value of x is belongs to 0, pi. Okay? We'll consider the first interval, the value of x belongs to 0, pi. You know the graph of the sine function. So this will be like this, right? So this is 0 and this will be pi by 2 and this is pi, this is pi and this is 3 pi by 2 and this will be 2 pi and so on, right? Now the value of x is belongs to 0 to pi, 0 to pi. The value of x is from here to here, 0 to pi. You can observe here the value of sine function will be positive. It is above this one, right? So obviously this will be positive. So since the value of x belongs to 0, pi, sin x will be greater than 0, right? The value of sin x is greater than 0. And what will be the function? F dash of x is minus sin x. So sin x is greater than 0. So minus sin x will be, if you multiply by the negative sign, then the inequality will be reversed, right? You have studied this one in the linear inequality. So f dash of x will be less than 0. Is it clear? The function sin x will be greater than 0, but f dash of x is minus sin x. So f dash of x will be less than 0. By this we can say that the function f is decreasing in the interval 0, pi. Is it clear? We'll check the second one, B. Now what we have to consider the interval since x is belongs to pi, 2 pi. Now the value of x is between pi to 2 pi, where it is from here to here, right? Pi to 2 pi. Pi to 2 pi means the sine function is negative, right? So the sine function is negative. Now what happens? The value of sin x is less than 0. Is it clear? The function sin is negative, so sin x will be less than 0. Sin x is less than 0. So minus sin x will be, that is f dash of x will be greater than 0. Right? We are multiplying by the negative sign on both sides. If you multiply by negative sign, it will be reversed. By this we can write f dash of x is greater than 0. Is it clear? So this the function f is increasing in the interval pi, 2 pi. Is it clear? So the function is decreasing on 0, pi, increasing on pi, 2 pi. Now you have to prove this one. It is from 0 to 2 pi, from here to here. Is it clear? The function is from 0 to 2 pi. So from 0 to pi it is decreasing, right? From pi to 2 pi. Which function? This one. Is it clear? This minus n function. So the function is from 0 to 2 pi. It is neither increasing nor decreasing because both are included. Is it clear? Finally what you have to write? By a and b. You write like this, by a and b. We can say that the function f is neither increasing nor decreasing on the interval 0, 2 pi. Is it clear? So 0, 2 pi. See, this type of problems are important. We'll read the question. Find the intervals in which the function f of x is x square minus 4x plus 6 and the function is given. You have to check where the function is increasing and where the function is decreasing. Simple it is. What you have to do? First we will consider this function f of x is equal to x square minus 4x plus 6. As I told you, to check the increasing and decreasing, we have to differentiate function. So we will differentiate this function with respect to x. Okay, derivative will be now f dash of x is equal to x square is 2x minus 4 and derivative of plus 6 will be 0. Now what you have to do is you have to equate this one equal to 0. I mean f dash of x is equal to 0, you have to equate. Is it clear? Now we will equate this one. After this step, f dash of x is equal to 0 implies that 2x minus 4 is equal to 0. Okay, so this is now 2x will be equal to 4, x is equal to 2. Is it clear? We got the value of x as 2. I mean, if you substitute the value of x as 2, this function will be 0. Is it clear? If you substitute x is equal to 2, 2 into 2 will be 4 minus 4 will be 0. So the f dash of x will be 0. So it is a constant function. Now, what you have to do is this 2 divides the real line into the number line into two parts. Okay, this is a number line. Here minus infinity is there and here plus infinity is there. Somewhere this value 2 is there. This 2 divides the number line into two disjoint intervals named as minus infinity 2 and 2 comma infinity. Is it clear? The number you have to write, the number 2 divides number line or real line into, is it clear? Real line into two disjoint intervals. What are the intervals? One is towards the negative, so it should be minus infinity to 2, minus infinity to 2, and another one is 2 to plus infinity, so 2 to plus infinity. Is it clear? Now you have to check where the function is increasing in this interval and where the function is decreasing. We have the value of f dash of x is equal to 2x minus 4. Now if I consider this interval, okay, right here we have f dash of x is equal to 2x minus 4. Now consider any value. This is between minus infinity to 2. I mean negative values is also possible or 1 is also possible. If I substitute 1, what happens there? 2 minus 4. You will get the negative value. If I substitute minus 5, then minus 5 into 2 will be minus 10, minus 4. Again it is negative, right? Substitute any values between minus infinity to 2. If you substitute 2, it will be obviously it will be equal to 0. Then the value of x should be less than 2. Then obviously you will get the negative value. Is it clear? So the f dash of x will be less than 0. Where? In the interval. Is it clear? In the interval minus infinity to 2, f dash of x is less than 0. In the interval minus infinity to 2. So the function is f dash of x is less than 0 means it is decreasing, right? So the function decreasing in the interval, minus infinity comma 2 or and if I check with this one 2 to infinity, right? 3 you substitute. 2 into 3 will be 6. 6 minus 4 will be positive. So all the values greater than 2, f dash of x will be greater than 0. Is it clear? If you consider any value in this interval, the value of f dash of x will be less than 0. So it is decreasing. If you consider in this interval 2 to infinity, the value of f dash of x will be greater than 0. So the function is increasing in the interval 2 comma infinity. I hope you understood this one. So the function f dash of x is equal to 2x minus 4 is greater than 0 in the interval what is the interval now? 2 to infinity. So the function, therefore the function f is increasing in the interval 2 comma infinity. Okay. So the function is decreasing in the interval minus 2 to infinity. So minus infinity to plus 2 and the function is increasing in the interval 2 to infinity. See this problem. similar to the previous one. Find the intervals in which the function is given and you have to check where the function is increasing and where the function is decreasing. I mean, we need to find the intervals. First, what you have to do, we'll write the function as it is. F of x is equal to 4x cube minus 6x square minus 72x plus 30. First, what you have to do, differentiate it. Differentiate the function with respect to x. So, derivative of f of x will be f dash of x is equal to x cube will be 3x square, 4 into 3 will be 12x square minus x square is 2x, 6 into 2 will be minus 12x minus this will be now 72 and derivative of 30 will be 0. Now here 12 is common, right? 12. So we can write this one as x square minus x minus 6. Is it clear? Value of x, you have to equate this one equal to 0, right? Obviously here the quadratic equation is there. So I'll get the two values of x. Before that, we'll simplify this one. So this one can be written as 12 into x square. I can write minus 3x plus 2x minus 6, right? Minus 3x plus quadratic equation simplification. This is 12 into, I can take x common. So this will be now x minus 3. Here also it should be x minus 3. So this is now plus 2. So values are here 12 into x minus 3 and x plus 2. Is it clear? Just we have simplified this one. Now we will equate this one equal to 0. Now f dash of x is equal to 0 implies f dash of x is now 12 into x minus 3 into x plus 2 is equal to 0. By this 12 can't be equal to 0, right? Either this should be equal to 0 or x plus 2 should be equal to 0. So we got the value of x is equal to 3 and x is equal to minus 2. Is it clear? So two values are there. These two values divides the interval. For example, divides the number line. So we'll consider the number line. So this is 3. Somewhere here 3 is there and here minus 2 is there. Is it clear? So this 3 and minus 2 divides the number line into three parts. One part is this one, right? Another part is this one, another part is this one. Because there are two values, it divides into three. If it is one value is there, it divides into two. What are the intervals? So 3 and minus 2 divides, is it clear? Divides the interval into, the number line or real line into three parts, in the sense three disjoint intervals. What are those? It is minus infinity to minus 2. If you substitute minus 2, it will be equal to 0. So one is minus infinity to minus 2, right? Another one is minus 2 to 3. Is it clear? Minus 2 to 3. And another one is 3 to, here it is plus, here it is minus. So 3 to plus infinity. I hope you understood this one. See, first you have to equate f dash of x is equal to 0. So that you got the value of x as 3 and minus 2. So this is somewhere here 0 is there. Okay, obviously plus 3 will be here and minus 2 will be here. These two values divides the interval into three parts. One is minus infinity to minus 2. Another one minus 2 to 3 and another one is 3 to plus infinity. Now we have three values and you have to check where the function is increasing and where the function is decreasing. Now we will check with the first interval. Let us consider minus infinity to minus 2. So if you consider any negative value, here we will consider any negative value. I will consider minus 6. So this will be minus 6 and minus 3. Always obviously will get negative value, right? Here minus 6 plus 2. Here also get negative value. Negative into negative will be plus, right? So in the interval minus infinity to minus 2, the function f dash of x is greater than 0 or f dash of x is greater than 0. Is it clear? Now we will check with the second one. It is minus 2 to 3. Minus 2 to 3. Minus 2 to 3. 0 is there, 1 is there, 2 is there. We will check with 1. If I substitute 1, so this is 1 minus 3, I will get minus 1. Here 1 plus 2, I will get plus value, right? Anyway, this is plus. and minus into plus will be minus. So we'll get the negative value. Is it clear? By this we can say that f dash of x is less than 0. In the interval, this one it is greater than 0. In interval, this one the function will be less than 0. Now third one is there. We'll consider the interval in 3 comma plus infinity. All the positive values, right? More than 3. If I substitute 4 minus 3 will be, obviously it is positive, right? Here 4 plus 2 positive. So positive into positive will be positive. So the function f of x is greater than 0. I hope you have understood this one. See, this is in this it is greater than 0, and in this also these two it is greater than 0. In this interval the function is less than 0. Finally what you have tried, the function, this is important, okay, the function f is increasing, okay, the function f is increasing in the interval, what is the interval, minus infinity to minus 2 and the function 3 to infinity.